Hey guys, how's it going? So this is just a quick update on my project here on wireless power transfer. And here I got the Class C amplifier driving the resonant tank circuit on the transmitter side. And just for the record, I have here the receiver side with this little spacer over here, so they are definitely not connected. The coupling coefficient is quite small. It's in the order of k equals 0.3 as measured before. And right now I'm driving, I'm not driving it, but I'm gonna turn it on, and the frequency that I'm driving it at is 187 kilohertz. So I'm gonna turn on the function gen, and here in the scope I have channel 1 connected to the transmitter coil here. So this is channel 1, and it's measuring the ringing of the transmitter, whereas channel 2 is connected to this little capacitor here, which is smoothing the rectified waveform that is being received in the receiver. And my multimeter here is measuring what is the current that is going to the LEDs. I have here 24 LEDs, and now let's see how the circuit performs. So I'm gonna crank up the voltage here in the transmitter side, and we're gonna see the LEDs lighten up as I crank up the voltage, and they get quite bright. So right now I'm at 8 volts in the transmitter side and 0.2 amps. This is the transmitter current measurement. And let's take a look at the waveform in the scope here. So we have, I probably should trigger from channel 1. There we go. Okay, so it's not that screwed up. Okay, so right now we have a peak-to-peak voltage of 32 volts in the coil, whereas I'm receiving 5 volts in the receiver after rectifying it. So this is the voltage after rectifying, and I'm drawing 0.11 amps. So it's quite a lot of voltage, but I want to make it to the design voltage. So let me crank it up a little bit more. There we go. So 12 volts, 0.35 amps, and this, so 12 times 0.35 equals 4.2 watts. So this is the power that is being consumed in the transmitter side right now. And we have in the receiver here a RMS voltage, channel 2 RMS voltage of 6.4 volts. So 6.4 times, now the current being drawn, since the voltage is a little bit larger, is 0.2 amps. So 0.2 amps is 1.28 watts. So this is the total power that is arriving in the receiver. So now let's divide 1.28 by I don't remember, 12 times 0.35, right? So it's 30% efficiency. So that's the efficiency of this wireless coupling circuit, as screwed as it is. And for me it's quite an achievement. Of course it's not exactly the most efficient circuit, but I'm quite happy with it, and I'm gonna move on to my project. So now we have, since I cranked up the voltage up until 12 volts, right now we have a peak-to-peak voltage of 44 volts. But actually, it's measuring the ringing too. The peak voltage is actually 10 volts per division, 30 volts. So 30 volts is the peak-to-peak voltage in the transmitter coil, which is quite a large voltage, but it's still working. Of course, the MOSFET is absorbing most of the power, and we can see here the light is actually blinding. Like, this is a lot of light. Oh my god, like, look at the amount of light that is coming from it. I'm quite happy with it. So thanks for watching, and have a good one. Bye bye.